Alright, here's another problem from ALEKS. A chemist makes 540 milliliters, I see three sig figs there, of zinc oxalate working solution by adding distilled water to 290 milliliters of a 48.5 micromolar stock solution of zinc oxalate in water. Calculate the concentration of the chemist's working solution. So he has something that's concentrated right here, and he wants to dilute that into 500 greater volume, 540 milliliters. So let's remember our dilution. Sometimes it's hard to even recognize a dilution problem sometimes, but the formula for that is going to be M1V1 equals M2V2. The one I like better is the same thing as concentration of 1 times the volume of 1 is going to equal the concentration of the second times the volume of the second. So when I get one of these, I know that I'm probably going to get 3 of these values right here, and I'm going to have to solve for the fourth. Generally, dilution problems are pretty easy. You just have to make sure you assign the C1V1 and the C2V2 correctly. So I always just write down this: C1 equals V1 equals C2 equals V2 equals. So I'm going to take this right here, and that's going to be my C1 and my V1. So the volume is 290 milliliters. The concentration is 48.5 micromoles per liter. My concentration, it's asking me the concentration, that's what I'm going to solve for, and the volume of the second one is going to be 540 milliliters. Now, because this is simple ratioing that we're going to do, you can leave the concentration in whatever units they give it to you. We can stick with micromolar. In fact, you can see that it wants the answer in micromoles per liter or micromolar. Okay, so since C2 is what it wants, I'm going to solve for C2 just right here. So C2 equals C1 V1 divided by V2. Alright, so I just rearrange this algebraically. You can do that in your head or practice it if you need to. So let's just start filling some things in. C2 equals C1, which is 48.5 micromoles per liter, times V1, which is 290 milliliters, divided by V2, which is 540 milliliters. Not sure why I trapped myself in this corner over here, but if I was to solve for all that, I'm going to get that C2 equals 26.0 micromoles per liter, or micromolar. That is the answer. It has the right number of sig figs. That should give me the correct answer in ALEKS. So again, to review, have to find out real quick, it's a dilution problem. I have a volume and a concentration, and I want to get to a new concentration of this particular volume. Alright, so recognize that. Know that C1V1 equals C2V2. Concentration of 1 times the volume of 1 equals concentration of 2 times the volume of 2. I just solve for it algebraically. Sometimes you will have to find other concentrations or other volumes. So it's not just going to be concentration. Sometimes you'll have to find volume, and in fact many times in the lab, when I work in the lab, it's the volumes that I need. I know the molarity that I need to be at, so I have to make the right volume to get the dilution just right. Alright, that's it. Go team.